Welcome to clickmyproject.com.
A two-level FH-CDMA scheme for wireless communication system over fading channels. CDMA is a spectrum multiple access technique in which several transmitters can send information simultaneously over a single communication channel. Each user in a CDMA system uses a different code to modulate their signal. Choosing the codes used to modulate the signal is very important in the performance of CDMA systems. There are more codes are used as a modulation codes. We can choose the code in such a way that in which code provides good spectral efficiency. Multiple access interference occurs when more than one simultaneous users utilize the same carrier frequency in the same time slot. Two-level FH-CDMA scheme is used to reduce the multiple access interference, but the system has less number of possible users and data rate and high number of bits per symbol. Our new method involves multi-level prime codes for FH-CDMA. Multi-level prime codes increases the data rate and increases the number of possible users. This is the flow of our overall project. Multi-level, it consists of 5 modules: multi-level prime codes, CDMA, frequency band, time slot, and correlation. In multi-level prime codes, the modulation codes are partitioned into t number of groups. By using this, we can assign each user with one FH pattern and one of these t groups of modulation codes. It reduces the number of bits per symbol. Each user can use any one of group of the modulation codes, whereas in the existing system, the user can use only one group of modulation codes. It allows the different user to use different group of modulation codes. The next block is CDMA. CDMA is a spectrum multiple access technique. CDMA is a multiple access method in which several transmitters can send the information simultaneously over a single communication channel. It allows the several users to share a band of frequencies. In this method, the data signal is XORed with the code signal. Each user in a CDMA system uses a different code to modulate their signal. The separation of the signals is made by correlating the received signal with the locally generated code. The next block is frequency band. The modulation codes denotes which carrier frequency can be allocated for the particular user in a frequency band in a given time slot. For example, the modulation code for the user 1 is 031x2, then the user can use the only allocated carrier frequency in a frequency band in a time slot. The next block is time slot. FH pattern denotes the which frequency band to be used for the particular carrier frequency. For example, the user 1 with modulation code 031x2 and FH pattern as 024x13x, the frequency we allocated to the particular user. The next block is correlation. It is the process of finding the similarity between two signals to recover the original signal. We can use any modulation codes to modulate the signal, but choosing the best code that results good separation of the signal between the two users. The separation is done by correlating the received signal and the modulation codes. If the signal matches the modulation code, then the correlation function will be high and the system can extract that two signal. Two types of correlation methods are cross correlation and auto. In an autocorrelation, which is the cross correlation of a signal with itself, there will always be a peak at a lag of 0 unless the signal is trivial 0 signal. It is the method of finding repeating patterns such as the presence of a periodic signal obscured by noise or identifying the missing fundamental frequency in a signal implied by its harmonic frequencies. It is used to reject the multipath interference. The cross correlation is a method of measuring the similarity of two waveforms as a function of time lagging applied to one of them. The prime code, that is modulation code, has nothing in common with the signal. The correlation should be as close to as possible, thus eliminating the signal. This is referred to as cross correlation. Open the source code folder and main M file. The command window displays the FH pattern for the 6 users. these are the prime codes for six groups, and it is user one prime codes for 5 users. I here use 5 users, and FH patterns for 5 users. This is the output matrix, that is received matrix, and figure 1 shows the symbol for user 1, and figure 2 shows the symbol for user 2, figure 3 for symbol for user 3, and figure shows symbol for user 4, figure 5 shows symbol for user 5, and after that there is transmitted signal for the user 1 here, figure 6 shows, and figure 7 shows the transmitted signal for user 2, and figure 8 shows the transmitted signal for user 3. This is a cross correlation for the prime codes of remaining sequence. Figure 9 shows the transmitted signal for user 4. Figure 5 shows the figure 10 shows the transmitted signal for user 5. Figure 11 shows the received matrix for overall users, and then figure 12 shows the autocorrelation value of autocorrelation function, and here is displayed the bit array probability for number of simultaneous users. I here calculate for 45 users, and figure 14 shows the same spectral efficiency for 53 users, and figure 15 shows the spectral efficiency for 126 users. From this I conclude that our proposed algorithm increases the data transfer rate and increases the number of users by without any interference. Thank you.